Hello, everyone. Welcome to episode 58 of Reconstructing Cave Story. In this episode, we'll be implementing some heart drops for the player to recover some health if he needs it. The problem we're facing is some enemies need to be dropping hearts for our player to recover. Uh, there's two different types of hearts. There's the single heart and the multi heart. We'll probably only get to the single heart. Let's see. This is the single heart right here, this little red heart, this guy, and this white flash associated with it. And here's the multi-heart, which is just three hearts put together. So the single heart's worth 2 HP, multi-heart's worth 6 HP, just as a quick reminder if you haven't played the game in a while or anything like that. So let's talk about this special effect, this flashing. Why do we have a white heart and a red heart? So what's going on is for the first 7 seconds, we're going to just be flashing between red and white hearts. And it's going to start off flashing really slowly. It's going to be red, then it's going to be white, red, white, red, white, red, white, red, white, blah, 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 blah. And then it's going to, I say this flash period is steadily decreasing, but the number of times, so since the period's decreasing, the number of times that it's flashing in a given period of time is increasing. So finally, when it gets to the last second, it starts rotating between this red heart, this white heart, and then invisibility. So it just kind of flickers in and out of visibility, is in addition to being, in this red heart, white heart. So it'll rotate between these three states: red heart, white heart, and invisible. And then at the very end, for the last second, this is happening, but then also the flash period doesn't change anymore. It just stays the same, stays constant. And then for the very last few milliseconds, we see a white flash. Kind of its energy is exploding into the air, and that's going to be from this death cloud. That's where we're getting this white flash from. So we'll need that too. So our solution, instead of calling this a heart pickup or flashing heart pickup, I'm pretty sure missiles are going to work the exact same. We're going to call our struct a flashing pickup and just have a single constructor. It'll be a private constructor, which gets called by some named constructors. For example, we'll create a heart pickup named constructor, which will return a boost shared pointer with all the right things filled out, like the rectangle size, the value, the type, all that stuff filled out by these named constructors. But we'll just have a single private constructor which gets called for all those. Some other stuff we'll need to know is this line formula. We're going to use it for interpolating the flash effect. So we'll interpolate the flash period speed, the flash period. We'll have a start flash period and end flash period, which we'll be interpolating between. So we'll use the line formula where y is the current flash period, x is the current lifetime, and then we'll use y equals mx plus b. So filling this in, we'll get current flash period is equal to the slope, which I'll calculate in a second, times the current lifetime plus the start flash period. And so the slope can be calculated by, y2 minus y1 over x2 minus x1. And our y2, x2 is just how fast is it going at the very end. And our y1, x1 is how fast is it going at the very beginning. So we do in flash period, which we'll have to decide in a minute, and subtract start flash period. And since this will be a negative number, we'll have to do some interesting magic, and I'll get to that when it comes up. And then you divide by the end time minus the start time. But since the start time is just 0, we can just get the end time is the lifetime minus 1 second, or 7 seconds in. So let's call this 7 seconds so as not to confuse you too much. So anyway, just basic pre-algebra kind of line formula interpolation stuff there. So nothing too fancy going on there. And then all I have left to talk about are just some constants. The whole lifetime of the heart is 8 seconds, and then it disappears and you can't collect it anymore. The start flash period is, we're going to start off having it flash at 400 milliseconds. So it'll be 400 milliseconds red, then 400 milliseconds white. Then by the end of it, it'll be like steadily decreasing. So it'll be 100 milliseconds red, 100 milliseconds white. So it'll be really fast flashing kind of effect. And then finally, the dissipate time is just 25 seconds before the end. And we'll just show a little white flash, which is this death cloud thing. And then here's the collision box, which is just, just take the top left corner of the draw position and figure out, oh, the X is, so many game units in and so many game units down and so many game units wide and high. And you just kind of figure it out by measuring the pixels with that. And then the sprites is, I just have labeled where those are. And that's the other thing I'm going to do is instead of creating the sprite, no, that's not the other. I'll get to that in a minute. But yeah, I think this is all I want to cover for now. So let's get started. So let's start by opening up a new file, flashing pickup.h. And I made a neat little snippet to make this go faster for us. So flashing pickup h. Next one is flashing pickup, and we will make a derived pickup. So let's include pickup because we don't have it included right now. We'll also need to have sprites for this, so I'll go ahead and include sprite. And since we're returning shared pointers, I'm going to include boost shared pointer. So let's go into pickup and grab our interface that we're going to need to be implementing. Just paste it in. We'll get rid of this virtual stuff. So delete word, find equals, delete, next, q. Value and type are going to be pretty trivial. We're going to have these be taken in by our private constructor. So I'll create some values for those. So constant value, which will get set by our constructor, and pickup type, we'll call this type, which will also get set by our constructor. So let's fill these in. This is just going to return value, and this is just going to return type. All the rest of these will fill in our CC file. So let's declare our constructor and our named constructor. So let's start with our named constructor because I think that's going to be easier knowing what we want. So it's going to be static. It's going to return a shared pointer to a pickup, and it's going to be called heart pickup. And it's going to need to take in a graphics so that it can create the sprites. And then it's also going to need to take in a center X and a center Y. So units of game center X and units of game for center Y. And let's make some private data to store this. Let's store it in units of game X and Y, and we'll adjust it accordingly when we create it. So I'm thinking right now that we'll have, right now we have a heart pickup. We'll also have a multi-heart pickup, so we won't take that in as a parameter in case you're wondering about that. So let's go ahead and create our private constructor. So our private constructor is going to be a flashing pickup, and it's going to take in graphics, all these same things actually. So I'll just copy and paste these for now and forever. So graphics, center X, center Y. And then we're also going to need to take into our flashing pickup a tile X and a tile Y, because all of these flashing pickups are going to be on NPC sim, and if we just set the tile X and tile Y, the flash is always one to the right of our actual, like regular sprite. So yeah, I'll take in a tile X and tile Y. So units tile source X and source Y. Next, we'll also need to know the value and type, and then we'll also need a rectangle to calculate the collision rectangle from. So let's take in a rectangle first. So const rectangle. We'll need a place to store that. I'm just going to store it in a reference. We don't need to actually copy the whole rectangle over because they're all going to be stored, as constants. So it doesn't need to be copied over for any reason. So I'll store that in a const rectangle, member data. And then we'll also need to take in a value type, so constant value, and then const pickup type for type. And I believe that's everything we need to construct everything, but it's not all we're going to need for our, when we're constructing stuff. So we're also going to need to construct some sprites. So that's why we're taking in the graphics and the source X and Y. So we're going to need 3 sprites, right? This is the first sprite is the regular sprite, normal looking sprite. And then the second sprite is the flash sprite. And then finally, we need the dissipating sprite, which is going to be the same for all of them. So we'll just have flash sprite, and how about dissipating sprite? I like that. And I believe that's all we need for our header file. So we can go into our CC file now and fill out a lot of this stuff. So I'll open up the CC file, and that's not what I meant to do, but it compiles, so that's great. Open up a CC file and include flashing pickup.h, and then let's make some constants that we're going to need. So const, we'll start with a string, which means we'll need to include string. Okay, sprite name, which will be npc sim. Let's make some other constants too while we're at it. So like const k dissipating source x, and this is going to be at 1, and this needs to be a tile, so units of tile. And source y is going to be at 0. They're unused. Of course they're unused. I just made them. Okay, so let's actually create our constructor, and then we won't get those warnings. So we'll need to scope that in, change that to a colon, and start initializing everything. So let's start with our sprite. We need to initialize our sprite with graphics, k sprite name. Then we're going to use tile2 pixel source x. Same thing for y, except source y, and then width and height are all going to be 1. And that takes care of that sprite. So let's work out the flash sprite. Flash sprite next, which is just going to be at the same thing except source x plus 1. What? Did I spell something wrong? Yes, I did. Okay, so I didn't put a underscore at the end of that, so now it should be happy. So yeah, that's our flash sprite. If you didn't see it, it's same thing except source x plus 1. So let's copy and paste again. Let's create our dissipating sprite, which is going to be at, instead of source x plus 1, it'll be k dissipating source x. Source y will be k dissipating source y, and everything else is the same. Let's see what else comes next. Next, I think we need to initialize x and y. So we'll initialize x being at center x minus half tile. And then the same thing for y, except center y minus a half tile. And then we have rectangle value and type to initialize. So let's initialize rectangle with rectangle, value with value, and type with type. And that should do it for our, except it's not happy with dissipating sprite. Let's reorder this because it wants our construction order to match. So there we go. That should fix it. Okay, so now we have our private constructor. Let's create a public heart pickup. So here at line 17, we'll copy this over, and right above our constructor, we will paste it in and implement it. So instead of calling it static, we'll just leave that as a comment because it's not really static. Once you're outside here, it means something different. So let's scope this in as flashing pickup, heart pickup. And now we need to return a shared pointer to pickup and we will return a new flashing pickup, and let's initialize everything. So the first thing we're going to need is graphics. Easy. Center X and center Y we can just copy in, or just copy in from our parameters. Then we need to pass in source X and source Y. So I'm going to have a couple more constants for this. I'll do kheart source X and the same thing for source Y. Then we're going to need a rectangle, so I'll do kheart rectangle. And then value, kheart value, and a type, which we don't need to store as a constant because, you know, it's a heart pickup. So we'll just do health, I think. Nope, let's scope that in. Pickup, health. Yeah, there we go. And that should do it for that constructor. We just need to implement these three. So kheart source X and source Y. So let's do that up here. It'll be like our dissipating source X. So, but instead of dissipating, it'll be heart. So heart, oops. And it's going to be at, let's see, 2, 5. And then we also need to do the rectangle. This, I don't remember. This is const units. Nope, not units. Const rectangle, kheart rectangle. This is going to be, I believe, from here, 5, 8, 21, 19. And again, I just measured pixel values from there. Like 5 means it's 5 pixels from the left. 5, 8. And what was it, 19 or 21, 19. So that's what that is. And then kheart value, so const units of HP kheart value. That's going to be equal to 2 as well. And everything is all happy, so we can start implementing a couple more of these. What you call them? Methods. That's what you call them. So let's start with collision rectangle. That's going to be easy because we just need to add in our X and Y. So I'll just add these in at the top because that's where they are in the header file. I'll scope them in. This is going to be a rectangle starting at X plus rectangle.x, or left. Y plus rectangle.top. And then just rectangle width and height, so DTR. So that there is our collision rectangle. Now we need to draw an update. So I'll start with update. Update's easier. So update is going to be flashing pickup. And this flashing pickup is not actually going to use elapsed time or map. So we can just hide those. So let's return our timer.active, which means we'll need to create a timer too. So let's do that first. So inside of our H file, let's include timer. And down here, probably below units of game, let's add in a timer and initialize it. So, which means we'll need to add in some time constants too. Oh, well, let's start with just initializing it to be timer, k lifetime, and we want it to start active, so we'll say true. So let's implement k lifetime. So const units, milliseconds, k lifetime. I said this was going to be 8 seconds, so 8,000 milliseconds. And now we can go to update again and return timer.active. Phew. Let's call it flashing pickup instead. Okay, so now it's happy. Now we need to make sure that we are correctly updating our current flash period. So that means we need to actually store our flash period. So right below our timer, let's also store our flash period as units of milliseconds flash period. We will initialize it to be our case start period. So how whatever our starting period is, which is going to be defined here in a second because I want to define it now. So let's go to the top and define some of these time constants. So we have k lifetime defined already, so that's done. Next, we need to do our start flash period. So our const units of milliseconds k start period, and we'll call that 400 milliseconds. And we also need to do the end period, which is going to be 100 milliseconds, and then our dissipate time and also our flicker time. And dissipate time is when we show this single cloud, this white cloud. So const units of milliseconds k dissipate time, and we'll call that at k lifetime minus 25 milliseconds. And then finally we'll need a flicker time, so when it starts going between red, white, and visible, red, white, and visible, at what point are we going to do that? And that is going to be our k flicker time. K flicker time is going to be 1 second before the end, so k lifetime minus 1000. So now we can get rid of these and get some sane errors. Okay, so there's one more thing we need, one more constant we need, and this is this line constant, this slope constant value, because we can calculate this as soon as we know the end flash period, start flash period, and flicker time. So this 7 seconds is really our flicker time. So let us implement this slope. And we need to be careful when we're implementing this slope because we are using milliseconds. So const float k flash interp. So this will be our interpolation. And so this end flash period is 100 and the start flash period is 400. So if we do 100 minus 400, you'd think, oh, we get negative 300. Not so in this case, because units of milliseconds are unsigned integers. So we need to be careful of that and make sure that we convert them to some other form, such as a float, that can handle negative numbers. So remember, unsigned integers are unsigned, so they can't handle signs. So that you'd end up with some big number and it'd be, it just wouldn't even work. So let's do our k end period, and to convert it to a float, we'll just do times 1.0f, and then we'll subtract off our start period, which is start period, and again convert it to a float, and then divide by our flicker time, so k flicker time. I meant to call that k flicker time, not k flicker timer. And that should do it. Now we can finish our update. So how are we going to update this? So we're going to set our flash period to be equal to one of two things. So if it's before, if timer.currentTime is less than our flicker time, then we need to use our interpolation. So k flicker time. And again, our interpolation, I'll go back to it, is just, I'll copy and paste it even, is just this current flash period is equal to the slope, which is our flash interpolation, times our current lifetime, so timer.currentTime, plus the start flash period, and this is k start period. And otherwise, we're just going to use the end flash period. We don't want it to speed up anymore after our flicker time has arrived. So that covers the update method. Now the only thing left is the draw method. So let's fill in draw. I'll start by scooping it in and give ourselves some curly braces. And the way I'm going to do this is I'm going to work backwards, starting with our dissipation frame or dissipation section of our, drawing period. So I'll just say if timer dot current time is greater than k dissipate time, and then the next case I want to work with is if we're in the last second of our lifetime or in our flicker time period. So else if timer dot current time is greater than k flicker time, and then otherwise we are before our flicker time, and we'll handle that case then. So if we are past our dissipate time, that means we want to be drawing our dissipation sprite. So dissipating sprite dot draw, giving it graphics X and Y. So now I'm going to skip over the flicker time section because the otherwise section is a little bit simpler. So we're going to be, again, remember, going back and forth between red and white. So we'll say if our timer dot current time divided by our flash period modulo 2 is equal to 0. That means we want to draw the regular sprite. So sprite dot draw graphics X, Y. Otherwise, we want to be drawing our flash sprite. So else flash sprite dot draw. So that's pretty straightforward. Now it's a little bit different for our flicker time, but not too much different. But instead of doing modulo 2, we're going to do modulo 3 so that we can break it up into chunks of 3. So we'll say if timer.current time divided by flash period modulo 3 is equal to 0, then we'll draw our sprite. Otherwise, if, and then we'll do this check again. But instead of saying, oops, not that check. This check. Otherwise, if our flash period modulo 3 is equal to 1, then we want to do our flash sprite.draw. And then otherwise, we don't want to draw anything, so we can actually eliminate that case. So the only thing I'm doing different here is I'm breaking it up into chunks of 3. And then I'm checking to see if it's the first chunk, otherwise the second chunk, and then otherwise we don't draw at all. So that'll make it flash between, or that'll make it flicker. So now we can go to game CC and actually use this heart pickup instead of our power Dorito pickup. I'll move it out here. And instead of adding a power Dorito pickup, I'll need to add a heart pickup. So let's go up to the top and add in or include our flashing pickup. Pickups. And so let's add in our flashing pickup. So it'll be flashing pickup, heart pickup, giving it graphics and center X and center Y. So that's right here. I need another parenthesis. Okay, so now let's test this out. Comma G. So when I shoot him, I should see heart. It's flickering. It seems to be speeding up. It's going faster, 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 faster. Okay, now it starts flickering out and it disappears. So yeah, that's almost exactly what I want. I think the heart is a little bit off. And let me make sure also that I can pick it up. So let's see. Yep, I can pick it up. But I think for our final flash period, I'm going to change this up a bit because that was going too fast at the end. So maybe Hmm. So maybe I'll do something like make it a bigger period, like 150 for our end period, and then I'll have another period for our flicker period. So our flicker period is going to be maybe a third of this, but I think 50 milliseconds would be too slow. So maybe I'll just do this to be 75 times 3 and I'll figure this out. So let's use our K flicker period instead of our K end period down here. And see how this looks. I mean, I don't know if you're going to be able to tell. Like, I don't know if the recording is going to seem right. So it's getting faster, 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 faster. Yeah, okay. So I like that a lot better, so I'm going to stick with that. And actually, that does it for this episode. I pretty much implemented everything I wanted to. It just kind of hangs out there, speeds up, boom, 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 goes really fast. Oh no, it's going away, and it's gone. So, yep. That's it for this episode, guys. Thanks for watching, and happy developing.